Welcome to the Self Workshop. Thank you for coming here today. My name is Remi. I'm co-founder and working at Self, which is an identity protocol that lets any third-party application, Web 2 or Web 3, to verify the identity of their users while letting them stay fully anonymous. So the plan about today is first for me to give you a better understanding about the project, what is the vision behind. Then we can talk about the bounties, because we have like a total of 10K for this hackathon. And finally, we'll see with Nico and Ayman to see code implementation and how you can integrate the SDK on-chain or off-chain. So why Self exactly? So let's say that you're an application that needs to verify the identity of your users online. Today, you are probably going through the traditional KYC process, which is extremely painful. I think I did it something like 5 or 6 times in the past few months, and each time that's such a pain. You need to find your ID documents, scan it, send the information, and then wait until the verification. And also you need to pray that these information that you are going to send and that are going to be stored inside database are not getting hacked. And like this kind of hack, this can happen, of course. So this is definitely not secure, and even from the application point of view, that's not secure neither, because using generative AI, now it's childish to generate fake image of ID documents or use or just use deepfakes, for example. So yeah, definitely not secure at all. So how can you solve all these issues at once? Well, I think that's the moment for me to talk to you about biometric passports, because these are pretty cool. So biometric passports, you can know if your passport is a biometric one if there is on it this little logo, which means that inside the passport there is a biometric chip which contains all the data that are signed by the issuer country, meaning that you can verify this signature inside the zero-knowledge proof. And this is exactly what you're going to do using Self. So by doing so, you can already generate a ZK proof that you own a valid passport, meaning that you're a real human. But you can do even more than that, because you can prove that you can basically prove anything that is related to the information that are stored inside the passport, such as I'm above 18 years old, I'm part or not part of a specific country, or that I'm not part of the OFAC list, for example, without revealing anything else, which is extremely important. So right now we are supporting biometric passport, but we're also working to extend the support to other ID documents, such as the Aadhaar, which is a local ID solution in India, or the EU ID cards. And if you don't own a biometric passport, that's not a problem if you want to try to hack on Self, because you can generate mock passports within the application, but of course you can't use this one in the real life. Anyway, so what does look Self exactly? So for the end users, he's going to open up the mobile application, scan the passport using the camera. It's just reading some fields, then scan it using the NFC reader of the phone. This is maybe the tricky part. The NFC chip can be on the back cover, on the middle cover, or in the front cover. And then you are going to generate a ZK proof in which you are going to verify the digital signature of the passport. And then that's it. You are good to go to use Self. So from the developer perspective, you are going to, in the front end, generate a QR code that people are going to scan using the Self application. And it's going to be prompted inside the mobile app the different disclosure attributes that the user will need to disclose. But you won't learn anything else beside this information. So as a user, I will scan the QR codes, generate another ZK proof, and send it to the third-party application. So what can you prove exactly using Self? As I said, anything that is related to the passport information. Like birthdate, for example, we are running a small experiment in which if you can generate a ZKP that your birthday is in the current week, you can earn $100, which is pretty cool. Then there is the expiry dates, the name, the surname, the passport number, the gender, the fact that you are above a certain age. There is also the nationality, the fact that you are not part of a given country list or not part of the OFAC sanction lists. So the last one are extremely important and extremely interesting for compliance, and we would love to see them in real DeFi applications. All right, so let's talk quickly about the bounty. So we have a total of 10K for this hackathon in 2 categories. The first one is on-chain, and the protocol is based on Celo, meaning that if you decide to verify the proof on-chain, you can cumulate both the prices of Celo and the one of Self. And the second one is if you want to verify the proof off-chain, so in a node server, for example, or on another blockchain. All right, then Ayman, if you want to talk about the code example.
Yeah, so how do you go about integrating Self into your app? So there's 2 components that you must look out for. There's the front-end SDK, which has the QR code component, and what this QR code encloses is the disclosure options you want to verify for your user. For example, you can configure your QR code to have your options to be where you want to generate the proof, the date of birth of the user, and whether you want to verify it on-chain or off-chain. That's the first component, and the next component is the backend SDK. So the backend SDK verifies the proofs, and this can be either on-chain with our contracts SDK. So this involves extending an abstract contract and overriding a function, the verify self-proof function, or it can be off-chain, which is a NodeJS SDK where you can just verify your proofs on the server. So this is what the QR code will eventually send the proofs to. So how does this work? So you generate the QR code on your app, on your web, or you can do it on a mobile app. And what you're going to do with your self app is, what you're going to do with your self app is you're going to scan this QR code, and once you scan it, you get all these options that you want to disclose. So once you approve this request, your passport details get encrypted and sent to a TE server, and that's where the ZK proof is generated. It is generated by us, and that's sent to the contracts, either depending on whether you want to verify it on-chain or whether you want to do it off-chain. And yeah, the QR code and self-app listen to the contracts or the backend verifier, and you get the verification result, whether it's a success or failure or not. So how do you do this in the front end? So you see it, you have this QR code component and this builder component, and you have this endpoint that you have to specify. So if you're doing it off-chain, then you need this endpoint to be accessible everywhere, because our TE servers are going to call this endpoint to verify your proof. And the endpoint type is either Celo or HTTPS or like there's other options in our docs, whether you want to do it on-chain or off-chain. And you can see here it's so this app, for example, is the Happy Birthday app. And what we did was we started this in ETH Denver. If your birthday lies within 1 week of today, like a 1-week window, then you get 100 USDC sent to you. So what we are doing here is we are disclosing the date of birth and checking whether your date of birth lies within the 1-week window. And yeah, you wrap this up in a QR code component and scan it with your self app. Nico will talk about how you can do the contract integration.
Okay. Okay. So I will explain how to integrate our backend side to your applications. So there's 2 ways, as explained the Aymans. There is contract integrations, contract verifiers, and Web2 verifiers. But for the Web2 verifier, it's not really hard to integrate. There is a great documentations on our website. So I would give you a little bit explanation how to integrate a contract to your applications, and it's more like price, right? So we have example applications named Happy Birthday. Happy Birthday contract is so verify the data in the passport and label your date of birth to our applications, and verify your date of birth is between 5 days windows from today, And if it is 5 days windows, then like you can get $100 or something. So how to integrate our contract? First, you need to import and inherit self-verification root. This is an abstract contract, and you inherit this contract and then initialize with these values. And then there is one function named verify self-proof, and you will override that function and write your own verification method in that functions. Why we have this abstract contract is because we have infrastructures like applications or TE servers to generate a proof, and that TE server will automatically call your contract. So we need to have some fixed an interface for that. So this is why we provide abstract contract named self-verification root. So right now I don't really deep dive into each values you need to input for an initialization of self-verification root. You can go to our docs, or you can just come to our booth and ask some questions. But first, what you need to do is you just import this contract and initialize in your contract. Then after you initialize, you need to write your own verify self-proof functions in your contract. So first override our functions. And there is 3 basic verification you need to, I recommend you need to add into your smart contract. First is a scope verification, and the second is a attestation ID verification, and the third is a proof itself verifications. So scope verifications, scope is kind of the name of your applications. So we verify, so you need to verify it, that proof is generated, supposed to do use for your applications or not. So I recommend you to add this scope verifications. And also you should add attestation ID verification. So attestation ID is identifier for each document. Currently self is only support the passport. So right now it's not really matters. But future we going to support other ID card, digital ID card, for example a EU ID card, adult. So for that we added this kind of identifier. So it's not really matter right now. I recommend you to put this verifications in your contract. And the third, of course, you should verify the ZK proof, the gross 16 proof in your contract, of course, right? And of course, and then not only these basic verifications, you can utilize attributes which is inside the passport. So inside the passport, there is so many personal informations name or date of birth, gender or nationalities. And also not only verify those direct values, you can also prove or you are more than certain age, or you're not from certain countries. So it's also I'm not really deep diving into how to verify each attributes here, but basically what you need to do is there is so in a public inputs of our proof, there is a reveal data packed field in our proof. You can find the index of these values in our contract. There's a contract constants. And then there is a 3 array of the uint 256. So first, you just get the reveal data packed for 3 uint 256, and give it to our our library named formatter, and get our 1 packed bytes data. And then 1 packed, and then you extract some part of the data in the 1 bytes data, and for example for this you can get the date of birth from 1 bytes data. And then you can get the date of birth. And for the happy birthday contract, we need to change play with this date of birth, because date of birth in the passport is that year. It's also included the year you're born in, but we just want to get the month and date for to verify, to compare with the current date or not, right? So I added some lines of code to play with the date of birth. If you want to play with date of birth, happy birthday, then you can just copy it. but maybe like there's more use cases. Like you have more ideas on the contracts. Like I can help you how to play with other attributes in the passport. So like you can just come to our booth, or like it's also we have documentations on our website. So like there is explanations of how to integrate a contract, or like how to integrate our backend verifiers. So like yeah, you can just refer it first, but it's also like, come to our booth if you got questions. And this is a link to our GitHub, and this is a link for our website. So yeah, you can just come to this webpage. So yeah, this is pretty much everything, and I pass it to the Remi.
Thank you, Nico. Yeah, one point that I would like to raise is just make sure that you are going to put the same arguments in what you are going to ask the users to disclose, and then what you want to use in the backend, like in the backend or in the smart contract. Because if you want to access to, let's say, the passport number or the name and surname, you need first, in the QR code, to let the users disclose it. Because they are not going to reveal anything besides what they are going to verify inside the mobile application. So that's super important to know. Then I think we're good to go. Yeah, thank you so much for your time. And if you have any question, we'll be pleased to answer to them. So we used to do client-side proving, but we switched to TEs now. So the proof is generated inside TEs. And like, of course, the end game is to use back client-side proving. But because the countries, they are using different signature algorithm and hash functions, there is a map that you can see on map.self.xyz. It's extremely hard to, like, there is a bunch of ZKs that people should download in order to generate the proofs. And you can't ask people to download like a 10 gigs file in order to generate the proof. So right now it's in the TE, and we plan to move it back inside the mobile application. But we don't see the passport data, we don't store the passport data, it's just passing through the TE, generate the proof, and then go. Thank you. Any other questions? Yes, please. All right, so the passport data is only stored inside your phone, and that's it, inside the secure elements of the phone. We don't store it. Yes, sorry, you need to speak a bit louder, please. Yes. All right, that's a super good question. So the question is about the structure of the protocol itself, because I didn't detail it, but the protocol is actually in 2 times. First, you are going to generate a first proof in which you are going to verify the signature of the passports, and it's pretty similar to Tornado Cache or Semaphore if you are used to these ones. So first, generate a proof of passport inside of which you are going to verify the digital signature of the passports, and generate a commitment, which is a hash of a secret and part of your passport data. And you take these commitments and you put it on chain on the commitment Merkle tree, meaning that in a second time, you can reuse this commitment by doing this time a proof of inclusion of these commitments inside the tree and disclose any information related to your passport data. But this proof is extremely cheap, and we plan to bring it back extremely soon on client-side proving, because it's like totally adapted to ZK proving. It's just Poseidon hashes, no signature verification. All right, we still have time if there is other questions. All right, so on the left, you have the link to the GitHub. Everything is fully open source. So you can just check the repository, start it if you want. On the right, you have a link to the website, in which you are going to have like other links to the documentation, to the map I was talking about before, and a bunch of other information. We are maintaining a blog that you could check, that is named Not to Self. So yeah, please scan this QR code and check this out. All right, thank you.